Hi guys, we are into Halogen Derivatives, SN2 mechanism. Alright. Now in case of SN1 we already saw. In SN1 mechanism what we saw was it was only one of the two species which was involved in transition state. Now here what we observe is this is one species, same species as we tried in SN1 mechanism, T-butyl chloride reacting with hydroxide. Now what we find is in transition state this is also involved, both are involved. This is what? Species 1, this is what? Species 2. Both these species are involved in transition state, so we call it as SN2 mechanism. That's the first thing. Now substitution, why? Because Cl is going to be substituted by OH. Alright, so substitution. Nucleophilic, why? Because this is a nucleophile which is going to attack to carbon. Okay, so it does attack. So what happens in transition state? This is backside attack. OH does a backside attack, whereas Cl is here in the front side. Alright, so it's, you can see it's dotted, it's not bold line. So these are partial covalent bond. Alright, we also call it as penta-coordinate bond. Alright, because we know carbon can take only 4 bonds. It's tetravalent, right? So penta-coordinate bond or partial covalent bond in transition state, which is highly unstable. Alright, another thing that we observe is chloro is here, but OH is attacked from backside. Why? Why not from the front side? Because there are lots of hindrances, Cl, CH3, CH3. So OH cannot go ahead with frontal attack. So it does backside attack. Alright, because Cl is not quitting. Cl is also there. Alright, Cl also we know is a bulky group. CH3 also we know is a bulky group. C and 3 H's. So CH3 bulky group. So it does backside attack. Clear? So in case of SN2 mechanism, this is what is the transition state. I explained it well. So let's understand what happens in second step. In second step, Cl is out, minus Cl minus, and instead of that, OH has got attached. Now see, in this case what has happened, this was the structure, suppose. Alright, so assume that OH has done the backside attack. Now what happens is this leaves, right? ये यहाँ से छोड़ देता है ऐसे. Alright, so OH gets attached here. OH gets attached here, and see, this was like this, right? Now it becomes like this. It becomes like this. So OH is over here. So it becomes like this now. Alright, that's what you are seeing, right? It becomes like this. Earlier, ऐसे था, Cl was attached over here. So see, these are all H. But assume that this is CH3, this is CH3, this is CH3, and this is Cl. Assume it. Alright, there are different color codes, but I'm just for simplicity's sake, I'm just picking up this and trying to explain. तो अब यहाँ पे Cl था, alright, and OH पीछे से अटैक किया because of यहाँ से नहीं कर सकता because it's bulk. Alright, so it attacks from behind. Alright, so what happens is जैसे वो यहाँ से ये निकलता है यहाँ से, to get a better steric position, this becomes like this and OH gets attached here. So that is what you are seeing. So ये क्या हुआ? One which was like this, Cl attached there, it became like this. So inversion हुआ, Walden's inversion हुआ. Now you can check out. Cl was attached here, Cl यहाँ पे attached था, but the incoming nucleophile attacked from behind and inversion occurred. Alright. So basically what did we find? We found that Cl group one which was attached over here was on this side, whereas that is front side, whereas OH came from back side. So this molecule has OH here, this molecule has Cl over here. So इस चीज को तो क्या हो गया, उल्टा हो गया, right? This is what is known as Walden's inversion. Alright, so यहाँ पे क्या हुआ, inversion हुआ. Alright, so let's recap. Species 1, species 2, species 2 coming from back in transition state, both species attached. That's the reason why we call it as SN2. OH attacks from behind. Why? Because of steric hindrance. And these are partial covalent bonds, transition state, highly unstable. In step 2, what we find is Cl goes out, Cl minus goes out, chloride goes out, OH is an stable bond. Cl was attached here on the front side, but OH attacks from back side. So OH is attached on the back side. So this is what we call as Walden's inversion. Now if we observe in case of energy, now suppose if this is the energy profile, this is energy, this is reaction coordinate, as we saw in case of SN1. Step was bond breaking, second step was bond making. Bond breaking required more energy, whereas bond making required less energy. So we had two peaks in SN1, whereas in case of SN2 we have only one peak. Why? Because in transition state we only have this thing. Alright, that's about reaction. Alright.